Hey everyone, it's super exciting to be here. Welcome and thank you for joining. So I'm Akshay Chordiya. I'm based in San Francisco, originally from India, and I work as an Android developer at Tinder, um, helping people match. I'm also like Google developer expert for Android and Kotlin. And today my talk is going to be about Kotlin Flow. In this talk, by the end of this talk, you'll walk away with knowing how Kotlin Flow works, its internals, best practices of using Flow on Android and Compose, and how you can migrate to Flow, and most important, testing. So before we jump in, let's rewind a little bit and see how coroutines change the asynchronous programming world for Android. So coroutine, they allowed us to run any function on background, just on background thread by marking it as suspend, and easily switch back in between to any thread with the help of with context. In this case, to main thread, since we are calling the render function which touches the UI. And one key thing to remember is like suspend function can only be called from another suspend function or from a coroutine scope. And a coroutine scope represents the scope of a coroutine in which it lives in. And each coroutine needs a scope to run in. And so essentially that's the scope. And when the scope is destroyed, all the jobs running inside are also stopped or canceled. So this scope is generally associated to a lifecycle scope for simplicity. And for instance, like for Android, it's usually like associated with activity, fragments, view model, sometimes even application, etc. So Jetpack libraries like offer some predefined scope, like view model scope, which is tied to the lifecycle of a view model. And this provides the magic of clearing or canceling all the jobs running inside the specified scope when the scope dies, which in this case is when the view model dies. And the launch function is actually the one which is used to start the coroutine. It will immediately start the coroutine. There is also like async, which returns a future result. So this means that coroutines are hot in nature. And this is also one of the reasons why coroutines are not like a direct replacement for reactive libraries like RxJava. You can also like put it this way: a coroutine scope is kind of a subscription management system, which is like associated to the lifecycle. And this concept is called as structured concurrency, and this is what makes Kotlin coroutines so powerful compared to other reactive libraries out there, and also helps like developer prevent leaking the job or the subscription of your coroutines or your like reactive code. So what is Flow? So Flow is essentially a list of a code list or a collection. It's based upon the reactive stream specification, so it follows the same principle as RxJava. It has like bunch of operators like map, switch map, etc. And Flow is actually like built on coroutines, so it internally uses coroutines. We'll look into that as we go on ahead. And like I said, like it's cold in nature. So what makes it special? Like, why should you use like Kotlin Flow instead of like any other reactive library out there? So since like similar to Kotlin gave us like the type safety. Flow provides the same principle of type safety in the stream. That means you cannot send null values down the stream unless you say that it's nullable. So RxJava 2 has it too, but yeah, this just works like super nice with Kotlin. And then there is like interoperability between other reactive streams and coroutines. And this is the key thing. Like, so Flow provides like an easy API to convert a Flow to any other reactive library or the reverse. You can also like combine Flow and coroutines. We'll see examples of this later. You can also use coroutines and Flow on any of the Kotlin supported platforms like JVM, JS, native. There are like some issues on the native and JS side, but it does work for the most part. You can also use it in the common code and share it across your platforms. And it also has like fewer operators, and that also like means that it's like easy to understand the operators. And it has less number of operators because of two key reasons: because of extension functions on Kotlin, and the second one is like because all of these all of these operators are coroutines essentially, or like suspending in nature. That's why there is like one single operator to do synchronous and asynchronous code, which kind of like cuts down the number of operators. And not to mention the perks of structured concurrency, which we talked about. So flow is built on two key components. One is emitter and collector, where emitter emits a new value and the collector receives the value. So here is an example of an emitter. And this emitter is like returning a flow of string, very similar to how you would return a list of string. And so there are like various ways of creating a flow, one of which is using something called as flow builder. And so they are like functions provided by Kotlin coroutines library. It internally creates the flow for us. So we will look into that later. It's pretty cool, actually. And since flow is cold, nothing inside the flow builder block will be called until there is a subscriber or a collector observing the flow. So yeah, something like that. So let's look at the collector. So here we have the main function, which gets the flow inside the run blocking function. For people who haven't used coroutines, run blocking function is a blocking coroutine scope. That means it will block the thread until everything is completed. So we need a coroutine scope, since collect here is actually a suspend function. And like I said, like whenever there's like a suspending function, you either need a scope to call it, or you need to call it from another suspending function. Also notice the emit is also a suspending function, by the way. So let's understand how things work. So initially, the main function calls the stream function, and that will return the list of flow back. It will just do it like immediately. And then when we call the collect on the flow, this essentially will mean that we are subscribed to the emitter and ready to collect values. And then the emitter starts emitting the values sequentially. And the collector receives them and prints in this case. And so the same loop happens, and we are like emitting the next value, football in this case, and this goes on until the emitter has no values. That's when the execution moves out of the collect and is complete. So a quick analogy time. So imagine a tap of flowing water and a funnel or some kind of device installed to control this flow of water. And this water is essentially like getting collected in a bucket. So now imagine like the tap is actually the emitter. Water itself is your stream of data. The funnel here is the operators which allow you to control control your data or the water. And the bucket is the collector in Kotlin world or reactive world. So let's dive a little bit deeper and see how this is working internally. So as I mentioned before, like flow is based upon two simple interfaces, a collector and an emitter, which are like the bread and butter of this mechanism. I'll use tap emoji to represent the emitter and bucket as a collector in the next few slides, just for like easier for understanding. So when you create a flow using flow builder function, it internally creates an instance of a flow by implementing the flow interface. And this flow implementation like calls the block lambda only when collect is called. This is how like it ensures the cold nature of Kotlin flow. And the collector block here is actually emit, passed from the flow builder, which is passed to the unsafe flow API. This is, like I said, like this is how Kotlin flow ensures the cold nature. And the emit, which is the API of flow collector interface, sends the values to channel. Note that there are like different implementation of the flow collector interface, depending upon the type of the flow you use. I took like a simple one here to explain the mechanics of how it works internally. So coming back, you can see the whole mechanism of flow is just built on these two interfaces, like calling each other all the time. Plus, they are like suspending, which allows you to use coroutines inside them, or like channels, and also reap the benefit of structured concurrency, which is the best. Not only that, the flow builder function is suspending, so you can directly call any coroutine function inside the flow block. Any of your database operations can be also called inside that. So this is because like the flow block accepts a suspending lambda over here. And the same applies for almost all the operators. They allow you to run suspend functions in them. And this is a big part of the reason like why there are like less operators in Kotlin Flow when compared especially to RxJava. But let's dive into that later. So yay, less operators. So let's look at like core ideologies of Flow and how they make our lives easier. So with Flow, you can define or switch the thread by using an operator called as flow on. which takes in the dispatcher, which in this case is IO. And this operator sets the specified dispatcher only upstream. So anything above flow on will run on the IO thread. And the map operator below the flow on will most likely run on the thread which you launched the flow from. And so this this concept of preventing context from leaking downstream is called as context preservation, where the context is like encapsulated and it's never allowed to go downstream. So, so basically, there's like only one way to change the context of a flow, which is upstream. So raise your hand if you have used RxJava or still use RxJava. Wow, that's a lot of people. That's pretty cool. So if you raise your hand, then you know what I'm talking about here. So this RxJava code is like super confusing, especially for beginners to understand, like which thread their code is going to run on. Like in this example above, you can see that only the first subscribe on is applied and the other one is ignored. Now you see why context preservation is useful. Combined with another operator to change the thread, that is the observe on, which has like a different behavior. It's like a facepalm moment. And so exception transparency is the second principle or ideology of flow. So flow implementations like never catch or handle exceptions that occur downstreams. So they only catch exceptions which are happening upstreams. This is again like due to the context preservation which I was talking about before. And there's like only one operator to catch error in flow, which is like the catch operator, super obvious. So let's take the previous example of a flow which tries to get the value from the database and emit. As you can imagine, anything can happen when you're loading from a database, and it might throw an exception or something like that. So flow offers the catch operator very similar to a try catch block, which will catch any exception thrown upstream. So the value emitted from the catch is actually received in the collect. That means there's only a single place to catch all types of cases, either like success or failure, which makes it like super transparent, like when handling the cases of your code. The order of the catch operator matters since it only catches upstream exceptions. So if you like added it like way up, yeah, and there's like an exception downstream, it won't catch and your app might crash. So just, yeah, so anything below the catch might just throw an exception. So just make sure to add the catch operator like as last as possible, of course, like before collect. Yeah, like I said, like it would crash your code. And I would recommend to like toss in like sealed classes so you always cover all the cases, like success or failure or loading, no matter what, and handle them probably on the UI or show or toast, whatever your use case is. So as a general rule of thumb is use suspend for one-shot operation, like inserting into database or fetching from network. Those are like one-shot operations. And use flow when there's like a stream of data involved. For example, when you want to get data from database and update the UI whenever the data changes. So Kotlin Flow provides like a bunch of operators to manipulate your data stream. There are actually like less number of operators compared to reactive streams like RxJava. We saw like why that's the case, and the other reason was extension functions of Kotlin, and also like because operators are suspending. So imagine you have this flow of string with national park. These are some of my favorite national parks in California, by the way. We are applying operators like filter, map on this flow. So let's look at the first operator, filter here. What would it do is like, so essentially like you are filtering, wait, I think it got stuck. Wait, sorry, multiple slides, damn it. Internally, the implementation of filter function is like pretty straightforward. As you'd imagine, it emits the value when the specified predicate is true, else it doesn't. So the interesting thing to note over here is like what's transform doing and where is this emit function coming from? So the transform is an internal API which is creating another flow, and that internal API is like calling our lambda on collect, which for filter operator in this case would be the predicate logic. And notice that the filter logic is performed on collect. That is basically ensuring the cold nature of flow. Now, coming back to our flow of national park, with the knowledge of internals in mind, it's clear that each operator, except a few, hold the reference to the previous one, except for the first one. So, and each operator like creates an instance of another flow internally, sort of forming like a linked list. So this is how like Kotlin flow ensures the context of the upper streams cannot affect the context of the lower ones. And the data emission, of course, like continues to happen from in a top-down fashion. So, well, we saw like Kotlin, the flows are cold in nature. That means they're not executed until they are collected. And the data keeps flowing, meaning it's not stored, making flows stateless. So that makes them like perfect fit in our data and domain layer, like databases, use cases, and repositories. So let's take an example of how that fits in with MVVM. Imagine like you have a screen where you render the UI as per the state, which shows a list of messages, in which case you would have a repository or a use case similar as this, like a fetch message, which is the use case. And essentially like it's returning a list of messages wrapped in a flow. And then you would have you would use this use case in your view model, and then essentially create a state out of it. And you would also like apply distinct until change to prevent setting the same state to the UI when nothing is changed. And finally, in your UI controller, either like fragment activity, whichever you like to use, you would launch the flow within the lifecycle scope. FYI, there is a shortcut to do launch and collect together by using the onH and launch-in operator. It exactly behaves the same as launch and collect functions. Do note that if you don't call the launch-in after the onEach, your flows won't collect, meaning they won't emit anything. I have to like spend countless hours like thinking like why my code is not working because I forgot the launch-in operator there. So yeah, either put a lint rule or something, if that's helpful. So now in theory, like this does work, and you are able to represent the UI state. The problem with using flow for state is that each time the fragment is created, which would be like on a configuration change or for like multiple other reasons, like whenever the fragment is like recreated, the flow will always fetch new value every time the collector is attached, which means your network or database call will be made again, which is a waste of resource, right? It's even bad in case you had like another fragment to share, for example, to share the message as a bottom sheet using flow, using the same flow, because in that case, the entire database or network operation is like performed again. So that's when like state flow comes into picture. Unlike classic flows, they are hot in nature, and they can hold the current value. So let's dig in a little bit more and understand like what's it doing. So this is the interface of state flow, a minified version of it. Internally, state flows are essentially like implementing flow because they are a type of flow, and they hold a current value of the state, and they never complete. That's why you see nothing for the collect function. So how's that useful though, right? So that means that for the previous bottom sheet example, the state flow would immediately emit the latest or the current value as soon as it is subscribed, making them hot. And also they make sure to just emit distinct items, meaning you don't need to remember to call distinct until changed to prevent setting the same state again and again. So since state flows are immutable, that is like they're read-only, there are only like two ways to create state flow. One is like using the mutable state flow to create a mutable state flow. Too much state mutable stuff. Anyway, instance where you said, which you use to set the state. So creating mutable state flow requires passing an initial value, and depending upon your use case or how you share your UI, the initial value of your UI state can either be empty, load, or perhaps even null. Whichever is your use case. So now you just listen to these emissions from your use case and map it to the state. So you can set the value to the state using the state.value, and this will essentially like say to the state flow that emit it to all its collectors. So your UI controller will keep on looking the same. The difference being that as soon as we launch the flow, the UI will immediately get the initial value and then the state. So going back to the view model, Do you smell something here? So we are exposing a mutable variable outside the view model, which is not ideal. So the solution to that is like keeping the mutable variable private and exposing a read-only state to your UI logic. So fun fact, turns out this is a common use case and everyone's doing this way. And so Kotlin team listened to us or like they saw this. And with Kotlin 2.0, the Kotlin team is like introducing something called as explicit fields, which is like a convenient shorthand to expose your read-only state outside the class and keep the immutable one inside the class. Pretty cool. I like the Kotlin team listens to us or like makes these changes. That's why we love Kotlin. The other way to share state flow is using the state in operator, which allows you to convert a classic flow into a state flow. So the state flow operator actually takes in a coroutine scope, initial value, very similar to mutable state flow. The only difference to mutable state flow is that, so by the way, mutable state flow is always active, while the state in operator allows you to configure the strategy, the sharing strategy. And let's look at that actually. So the Kotlin coroutine dispatcher, like they have like, there's like 3 sharing strategies, like early, lazily, and while subscribed. So let's jump into the first one. With the early sharing strategy, the flow starts like it's essentially like emitting values as soon as it's created, even if there's like no one listening to it. And yeah, like, I mean, if there's no collector, it will still continue emitting the values. And the collector will only get the values emitted after it has like, it starts collecting or is subscribed. This is the same behavior as mutable state flow. If you use, instead of state in operator, you use mutable state flow, you would get something like this. So, and once the job is completed, that is like the flow is not collecting anymore, the state flow will continue emitting values. So essentially it's like a person who's like continuously talking, even though if you're listening or not. And yeah, so this will go on like till end of time or until the scope is destroyed. That's the beauty of structured concurrency. With lazily, the flow starts emitting values as soon as the first person arrives. And then it will continue to do same as eagerly, that it will continue emitting values even if there's no one listening to it. So it just needs like one person to start, and then after that, it's like even if the one person who was listening is gone, it will still keep on talking or like emitting values. And then there is like while subscribed, which is, I think this is a smart one. It like seems the smartest one. It only emits the values when there are like active collectors, which means like as soon as the first collector comes in, it's like, okay, let me send the values. And when there is like no collector, it will be like, oh, no one's here, I should stop talking. So that's how the while subscribed works. So coming back, it might be confusing, like when you should use the mutable state flow directly, or when should you use the state in operator. So use mutable state flow when you want to manually mutate the value, such as in view model where you have the UI events which may directly cause the state changes. And so and use the state in operator when you want to directly expose the state, like directly from the database or the network, and you just want to like expose it to the UI with a little bit of more control on when the emission begins and all the 3 sharing strategies which we saw. So similar to state flow, there is something called a shared flow. This is a more niche, and like it's not used as often. Mostly you will see that you might end up using state flow. That's the most common one, and that should cover most of your cases. But there are like some times when you want like a little bit more power, and shared flow is the one. So it's very similar to state flow. Actually, shared flow, like state flow actually implements shared flow to have the storage of value. So yeah, we'll look into that. So like I said, like it's very similar to state flow. It holds the current value. It actually holds a list of current values in the form of replay cache. So state flow can only hold one value, while shared flow can hold like a list of value. Yeah, and essentially state flow is actually a shared flow with the replay value of 1. Yeah, that's pretty cool, like how they inherit each other. Like, I mean, Stateflow inherits shared flow. So yeah, like I said, like similar to Stateflow, shared flow can be shared among multiple subscribers. It remains in memory forever, even though there are like no subscribers listening to it. So this is a gist of what shared flow provides. It allows you to configure how many values to replay to the collector, buffer mode, etc. But like, yeah, due to lack of time, we cannot cover all of these parameters. But you can use a new rubber duck to get help on it. StudioBot, ChatGPT, Bard, they're amazing. Just use them. Yeah, and this makes them like perfect if you want to like emit and collect repeated values like user actions, events broadcasted in the app. That's the use case for the shared flow. So similar to state flow, there's like a mutable shared flow which allows you to emit item to the flow. There's like a try emit function where you can like essentially pass a value. Lastly, similar to like state in operator, which we saw for Stateflow, there is like a share in operator, which allows you to convert any classic flow into a share flow. So the same logic of Stateflow applies like when deciding when to use the mutable shared flow or when to use this operator. Again, like this operator also allows you to customize the sharing strategy and the number of values to replay. So before we dive into testing, it's super important to understand dispatchers and how to set them up. So Kotlin coroutine dispatcher comes with like 4 built-in dispatchers, and that are designed like for specific use cases. So let's look into the first one. So default is the most common coroutine dispatcher. If you don't pass anything, the default one is used actually. And when a coroutine is launched with this dispatcher, it gets added to a queue of pending items. And the coroutine will then automatically get dequeued and executed by one of the worker threads in the pool. And this dispatcher is a good choice for most background tasks that are not specific to I/O. And then there is like, of course, the I/O one. So the I/O dispatcher, on the other hand, is designed for usage with coroutines or flow that perform blocking I/O operations. So these type of operations can take a long time to complete, and if they were performed on the main thread, they would essentially like make your app unresponsive or like cause ANRs, stuff like that. And this is the main is like super obvious. This dispatcher is used for coroutines that perform operations on the UI thread, and these type of operations are required to be like performed on the main thread because Android UI toolkit is not thread safe. And then we have this like special one, like unconfined. Unconfined coroutine dispatcher is like not confined to any thread, meaning that it will that when it is started, it runs on the thread which it was started, and when it is resumed, it just like uses the thread on which it was resumed on. So if I put it simply, we should use coroutines like the dispatcher, unconfined dispatcher, where we do not care where the coroutine will be executed. It's a good choice to avoid this altogether, especially in production, as this can make our code less predictable and even lead to like unexpected errors. So we saw best practices while looking at Stateflow, but let's remember that these are like recommendations and learning from what we saw and use at Tinder and what Google recommends. So most of us in the Android community use MVVM. Even if you use MVI, your architecture like kind of looks roughly the same. You end up using a view model, and the best practice is to use flows and coroutines in your domain layer as per your use cases. And in your view model, you would convert this flow or this coroutines into a state flow, and at the end, like your UI controller will just consume the state flow and render the state. There is a slight problem though with flows on our UI controller. Though they are like scoped to the lifecycle scope, they are not aware of background and foreground change which we have on Android. And that means that the view will still continue to receive updates even when the app is in background. And knowing Android, this can be an issue, especially true with Stateflow and shared flow, because they can emit even if there is no collector listening to it. So what's the solution for that? So to prevent this, Android team gave us like repeat on lifecycle API, which launches our flows or coroutines when the lifecycle is in the specified state or above, which in this case is created or anything above. Like after created, whatever is like there, it will be invoked after that. And it's automatically canceled when the UI state is stopped. So as a shorthand to do the same thing, there's like another API, Android team. It's the flow with lifecycle, which does the same thing, but just looks neater, cooler, and can be done in an operator chain. And yeah, no talk these days is like complete without talking about Compose, right? So luckily there's like only one thing to talk about Compose here. So there are like two key extension functions to consume flows on Compose. First one is collect as state, and that is like a new one recently, like collect as state with lifecycle. You can definitely use both of them. But after talking with them, I realized that collect as state is like platform agnostic, which is created to be consumed on platforms beyond Android. Since we can use Compose on desktop and other places, this is what you'll use, like collect as state. Well, the other one is tied to Android more, with like you can see in the name lifecycle. So collect as state with lifecycle is the safest way for Android, and it's internally actually using flow with lifecycle operator, which we saw, which prevents the flow to receive emissions when the activity is in a pause state. So this is one of the coolest things, and I love it a lot. Flow provides an amazing API to convert any legacy API to Flow. We use this quite often in our code base. So let's say you want to listen to text changes on edit text. You would create a function where you would update your UI when the do on text changes, whenever that callback is called, right? You would also need to make sure this listener is removed when the UI controller is destroyed, for example, when the activity is destroyed. And so Flow provides an amazing API called as callback flow. And what you would do is like you would just write, you can write the legacy listener or your callback, which you have, and then emit the value each time the text is changed. But you might be wondering, like, you need to remove this listener at some point, right? And then, so Flow actually, like callback flow provides a function called as await close, which is called when the flow or coroutine is canceled. This is the place where you can safely remove any listeners which you have attached. And the try send is actually the one where you emit the values. So yeah, coming to the migration, like let's look at how you can migrate from RX to Flow, since a lot of people here are using RX. The goal here is to not recommend to go this moment and migrate your entire code base to RX, to Flow. I mean, that would be great, right? But yeah, Flow and RX actually follow the same reactive stream specification. So in theory, it's like very easy to convert data streams between RX and Flow and reverse. So there are like two ways. First one is like you refactor your RX implementation to use Flow, but that's time consuming. And sometimes you might just want to like easily change the type and gradually move your RX code to Flow. In that case, you can use the as Flow extension, which allows you to like quickly change between flowable, observable to Flow. And the same can be done to convert Flow to observable or flowable when you need it. Here's a quick comparison of terminology between RX and coroutine. Use this chart as a reference, like when you're new to coroutines world or working on migrating from RX to Flow or reverse. Actually, yeah, that could be true too. The fun fact is like the as flow function, which we saw, is actually internally using callback flow to convert the observable to Flow, which is so cool. If your code base is stuck with RX Java and you want to move away, I would recommend to migrate to Kotlin Flow rather than migrating RX Java 1 to 2 and then Flow. Since RX Java 1 bindings are not officially supported by Kotlin team, a long time back I created this library which gives you the same API to convert your RX Java 1 types to Flow. So this offers like the API, same as what we saw for RX Java 2. You have this as flow function and as observable extension function to allow converting between both the types. So now to everyone's favorite topic, testing. So testing Flow or coroutine is like pretty easy. Let's take like a simple example of string. We want to test, and if this flow emits, we just like check if the expected value is there or not. So the first step is to use coroutine test rule, which allows you to test dispatcher which allows you to set test dispatcher for all types of dispatcher types like IO, main, unconfined, allowing you to run your tests immediately and synchronously. And then you want to write the test function and use the run test coroutine scope, because we want to test until or wait till our test is like actually completed, like the coroutine is completed. Finally, you call collect to list. So the entire flow emission are collected to a list, and then you can assert if the items are equal. There's also like cool libraries out there like Turbine, which you can use to test your flows. But this is like the bare bone way if you don't want to use any third-party libraries to test your flow. And then, though one thing important with testing is like you need to be like super careful with dispatchers, since coroutine libraries don't have a static function like RxJava to just change your dispatchers in your test. So let's look at like best practices to set this up for testing. So first step before you even start using coroutines or flow in your code base is like creating a wrapper interface, which allows you to inject dispatcher and swap it during the test. So very fun fact, it also keeps you open for Kotlin multi-platform in the future. And the implementation of the interface will delegate to the actual Kotlin dispatchers. Like for Android, we will use the Kotlin X dispatchers, which the Kotlin team has given us. And then you would inject this dispatcher interface, which you have created, in your view model. And then whenever you need to change the dispatcher thread, just use your interface and use the flow on operator and switch to that thread. And your test for the same would look the same. You essentially in your test, you just like override the dispatcher with the test dispatchers. For example, for this view model one. Yeah, and thank you for being with me on this massive knowledge transfer. You can scan this QR code to give feedback on this talk, which is super helpful for me to grow and continue sharing cool stuff. I'm happy to take questions if there's time. Awesome. Yay.